Hi, I'm Peter Ryan, the director of the Percy Fitzpatrick Institute at the University of Cape Town. I'm primarily an ornithologist, and I got interested in plastic because I did my master's degree on the ingestion of plastic by seabirds in the 1980s, and I've maintained an interest in plastics in the environment ever since. Over the last few years, I've been recording the amounts and types of litter from our research vessel as we go down from Cape Town at the tip of Africa into the sub-Antarctic, where we do a lot of work on seabirds and their conservation. It became very clear, as one might expect, that the density of litter was greatest close to the continent, and particularly around Cape Town, because most of the litter is from land-based sources. But what also became apparent was that the size of items and the type of items changed as we moved away from the source area. In particular, items became larger, and the proportion of flexible packaging in particular decreased dramatically as we moved away from the coast. And this got me thinking about what kind of processes might be driving this change in the amounts and composition of litter. And it's really very obvious, but nobody seems to have really put it together before. We've known for a long time that buoyant plastics, if they're fairly close to the density of seawater, can become fouled to the point where they sink out of surface waters. But the rate at which this happens is going to be controlled in part by the size of the item and also by the shape of the item, because buoyancy is a function of volume, whereas fouling is a function of the surface area of an item. And so for larger items, shape is really important, because the longer and thinner or more complicated the shape is, so the surface area increases quite dramatically. But as items become very small, then just the actual size becomes very dominant. And so very small items, if they are colonized by epibionts in the same way as larger items, will sink out much more quickly, because the surface area to volume ratio increases even faster than exponentially as things get smaller. And where we've taken this now, although we still haven't published this, is we've actually done some experimental trials to look at how long it takes things to sink out, and how this is related to the size and shape of items. And I think this is going to really help understand why the amount of floating plastic at sea is less than we think there should be based on the amount of litter coming out of continental areas.